In 1990, the mean height of women 20 years of age or older was 63.7 inches based on data obtained from the Centers for Disease Control, etc. Suppose a random sample of 45 women who are 20 years of age or older today results in a mean height of 63.9 inches with a standard deviation of 0.8 inches. Test the claim that the height of women has increased since 1990. Use alpha equals 0.10. So we know that mu is 63.7. We know x bar is 63.9, so this is the sample. And we know the sample standard deviation is 0.8. And then n is 45. So, my hypotheses, H naught, H1. So H1 is we are testing the claim that the height of women has increased since 1990. Therefore, it's saying mu is greater than 63.7. So H naught can either be equal to or less than or equal to. Remember, for H naught and H1, H1 is never equal to. It's always strictly greater than, less than, or it's not equal to. Don't ever have an equal sign with it. That's wrong, okay? All right, determine the test statistic. So we are using sample standard deviation. So are we using the T-chart or the Z-chart? We are using the T-chart. So our test statistic, T star, is x bar minus mu divided by sample standard deviation divided by square root of n. So plug that in your calculator.
We get this equation, right?
Yes, this equation is on your list of equations on the second page of the review.
And what's it called? What's this equation called? Again?
This is the test statistic for sample means. So we get 1.677. All right, so it says find the p-value and the critical value. So the p-value is something that we haven't done, so we're just not going to do that part. We're just going to do critical value on this one. So the degrees of freedom is 44. Looking on your chart, we don't have a 44, so we're going to use 40. Use the one closest. It said alpha is 0.10. So my t-value is 1.303.
Where are those charts?
Okay, so we're going to make a decision. So when we draw our rejection region, it is what type of test? Right-tailed. So that means we are looking at, that is my rejection region. Does my test statistic fall in that shaded area?
Yeah.
Yes, it does. Therefore, my decision is reject H naught. So the conclusion, there is sufficient evidence to conclude that the mean height of women has increased since 1990.
Question.
Hold on one second.
Wait, I thought our... Oh, wait, no.
All right. The number of families were interviewed and the number of children per family was determined. The random variable x is the number of children per family. Show that this is a probability distribution. So this is from a while ago. Who remembers what the main definition of a probability distribution is? It must add up to 1. Okay? So the sum of f of x has to equal 1. So 0.11 plus 0.16 plus 0.63 plus 0.10, and it equals 1. So we're showing, if it says is it, then your answer is obviously yes or no. The other way we could do it is I could have one of those missing, and I tell you it is a probability distribution function. Find the one that's missing, so you know that it's whatever it is that makes it add up to 1. Okay, so those are the different ways that it's going to ask that question. Use the table of data to find the expected value. Expected value is x times f of x when we're talking about a probability distribution function. So you multiply across and then add them up. So it's 0 times 0.11 plus 1 times 0.16 plus 2 times 0.63 plus 3 times 0.10. And you should get 1.72 as your expected value. For each of the following, determine the explanatory variable and the response variable. A researcher believes the origin of beans used to make a cup of coffee affects hyperactivity. He wants to compare coffee from 3 different regions, Africa, South America, and Mexico. So our explanatory variable is the origin of the coffee beans.
Whoa, I don't remember any of that.
This was first semester. And then the response variable, what are we trying to find out, is the hyperactivity level.
How do you remember this?
It's literally
Pretty
just what is being explained?
All right, look at letter B. A group of middle school students wants to know if they can use height to predict age. Take a random sample of 50 people at their school. Both students and teachers record each individual's height and age. What is my explanatory variable?
Height.
And my response.
Age.
And then a pediatrician wants to know whether watching TV causes girls to be overweight.
TV. Explanatory.
Explanatory is watching TV, amount of hours they watch TV, whatever. And the response is weight.
The amount of...
All right, determine the shape of the histogram below. So it is skewed left. Remember, you look at the tail to determine skewness. So it is skewed left.
The opposite of what it should be.
Okay, then state where the mean, median, and it doesn't say, but we're going to go ahead and say mode fall on the histogram. So when it is skewed, so first of all, remember the mode is always where your high points are.
Wait.
It's the high point, not the one you drew it on.
It's roughly where the high point is, one of those, okay? So you don't need to know exact, you need to know approximate. For your mean, think about it. If you have outliers to the left, what does it do? It pulls your mean to the left.
We're
So,
just like generally guessing?
yes.
Okay.
So this is the mean.
Wait, so is it to the left or kind of in the middle?
That's more to the
It is going to be pulled left. It's pulled towards the tail. And then where does your median fall
in between them.
Middle.
in between those two? So, when we did this, you have to know based off of skewness what order left to right mean, median, mode fall in. Do y'all remember that now? Okay. All right, below match the scatter diagram with the correlation coefficient.
Oh, I know this. I know.
Okay, so
A
first of all,
is C.
pick the easy ones. A is C. No, not C.
D.
D. Which one's C?
C.
Wait, what?
Is E.
E.
Hey, I thought we wanted.
Okay, remember this is a slope. This is close to positive 1. This one's close to negative 1.
E is C.
So that's E. This is A,
B is D.
right? All right, then now look at the other extremes. This one, going to be close to 0. Which other one will be close to 0? F, because it's going down then up. So we know that that's not going to be a good R. So A and F, the right side, this is either C or F, and this other one is either C or F. Okay? And then now, obviously, based off of positive and negative, you should know the others. this will be B, and the next, last one will be D. All right, back to hypothesis testing. So remember, this is a good decision. This is a good decision. This is a type 1 error, which we also know as alpha. This is a type 2 error, which we also know as beta. And then don't forget,
Power.
top left is power. So, how do we go about working this problem? First thing you need to do is identify H0 and H1. Otherwise, you're going to have no idea what it is that you're actually doing, which is what a lot of people were struggling with when we took the test. So, H0, H1. So, H1 is that mu is less than 30 because they said, I don't think it takes 30 minutes. I think it takes less. So, therefore, H0 is mu is greater than or equal to 30. So that's just my setup. That's what I needed to know. Now, define a type 2 or type 1 error for this scenario. So type 1 is we reject H0, but H0 is true. So that means we say it takes longer than 30 minutes when it takes 30 minutes or less. Did I say that backwards? Hold on.
It should be shorter.
Sorry. We say it takes less than 30 minutes
When it takes
longer than 30 minutes.
or 30.
Greater than or equal to, yeah. Is more than or equal to 30 minutes. Okay? Okay. Given this scenario, determine the units. So, mean is pounds. Standard deviation is pounds. Because variance is standard deviation squared, that means variance is pounds squared. And z-score,
Standard deviation.
no units. Doesn't matter what you're doing. Z-score does not have any units with it.
I thought it was how many.
All right, a study by Allstate Insurance finds 82% of teenagers have used cell phones while driving. Suppose a random sample of 100 teens is taken. What is the probability that the sample proportion is less than 78%? So we're finding the probability Z is less than 0.78. So the first thing I need to do is I need to find my Z-score. So go look at your formula, and you're looking for, excuse me.
Are we not doing the hypothesis?
So this formula is the same as test statistic. So we are going to find Z is 0.78 minus 0.82 divided by the square root of 0.82 times 1 minus 0.82 over n. So again, this is the same formula as test statistic. We get negative 1.04. So now we are going to find the probability. So the corresponding statement to the probability, sorry, I put the wrong thing. That's not Z, this is P. The probability that Z is less than negative 1.04, and that's where we go to the Z chart. So go look in what is your probability for negative 1.04.
Got you. 1492.
0.1492.
Isn't that the year that?
Actually, no.
What is the probability that the sample proportion is between 80% and 83%? So we're finding the probability that 0.80 is less than P is less than 0.83. So hopefully you remember, this is the same thing as the probability that P is less than 0.83 minus the probability that P is less than 0.8. So remember, we're talking area. If you're finding the area between two and the probability gives everything to the left, you do the right one minus the left one, and then it basically takes away that overlapping area, okay, and gives me what's left in between. So I have to find two different z-scores. Well, 0.80 minus 0.82 over my standard deviation. And that's negative 0.52. My second one is going to use the 0.83 value. So I find the probability that z is less than 0.26 minus the probability that z is less than negative 0.52. So two different probabilities from your z-chart. So you're going to get 0.6026 minus 0.3015. And your answer is 0.3011. Number 24, the following is a calculation for sample size. True or false? We always round this sample size to 16 because it's better to err with too many subjects rather than not enough.
True. What?
True. All right. Many people sleep on the weekends to make up for short nights during the work week. Better Sleep Council reports 61% of us get more than 7 hours of sleep per night on the weekend. A random sample of 350 adults found that 225 had more than 7 hours each night last weekend. Test the claim, 61% of people get 7 hours of sleep per night on the weekend. So, my H1, oh, sorry, these need to go down here. My H1 is that P is not equal to 0.61. H naught, therefore, is P equals 0.61.
How do I know when?
All right, so P hat is 225 over 350. I do recommend that you don't find that value and round it because, let me rephrase that. If you decide to use that value and round it, go extra decimals, because if you don't, if you truncate your decimal, it can cause you to have errors in all of your calculations because you're rounding. And then you round a rounded answer, and then you round that rounded answer because everything's being used. So either use it as a fraction, or when you do the decimal, go extra decimal places and then do it that way. Does that make sense? Because that was a lot of people I noticed on the test that were giving me this number as like 2 decimal places, and therefore your answers were off. So this is a multiple choice test. It has to match their answer. Therefore, you need to make sure that you don't mess that up. All right, so state the assumptions necessary for this test to be valid. So first of all, is it random? It says it is. NP and NQ. So 350 times 0.61 and 350 times 1 minus 0.61, which is 0.39. And both of those are greater than or equal to 5. And then my last assumption for probability is it binomial? And it is.
Yes.
Either you're getting more than or you're not. So it's doing that. And that there's binomial. Also remember that the probability doesn't change, and that there's a set number of trials. All right. Determine the test statistic. So z-score So 225 over 350 minus 0.61 divided by standard deviation. So we are going to get 1.26. We didn't state it, but what kind of test are we doing? We are doing two-tailed. So remember, that means when I find my test statistic, I am looking at the probability that Z is less than negative 1.26 and the probability that Z is greater than positive 1.26. Because it's normal, it is symmetrical, which means I really only have to find this one and then multiply by 2. Right?
Can you do -1 for one side?
I mean, if you do, it's fine. You're just doing extra math for the exact same answer.
Okay.
So if I find the probability Z is less than negative 1.26, that is 0.1038. And then I take that number and I multiply it by 2. And I have my p-value. So remember, now we are looking at this comparison with alpha, and we are either rejecting or failed to reject. For using the comparison with alpha, we are looking if it is less than. Less than alpha means we reject H naught. If it's greater than alpha, we fail to reject H naught.
It's less than. No, it's not.
0.2076 is greater than 0.05.
Oh, I was thinking 0.68
Nope.
or 6.1.
So that means that we fail to reject H naught. Conclusion, there is not sufficient evidence to conclude that the proportion of adults who get more than 7 hours of sleep on the weekend is different than 61%. Okay, compute a 95% confidence interval for this problem. So remember, 95% is the middle 95%. So we're looking at between 0.025 and 0.975. So I am looking at the probability that Z is less than Z equals 0.975. So I need to know that Z score. It doesn't matter, by the way, which end you use. It's the same answer. So when you go to your chart, looking where 0.975 is, you get that Z is 1.96.
And that's where the 0.975 is on her.
That's, yeah. And so now we're going to do point estimate, which is P hat, not P, P hat. And this, by the way, is also on your formula chart. It's, let me see, looking for it. Confidence intervals, it says it right there. So it is P hat plus or minus Z times, square root of P hat 1 minus P hat over N. So remember, the plus or minus takes care of, doesn't matter if you pick the negative one or the positive one because they're the same number. So this is going to be 225 over 350 plus or minus 1.96 times the square root of 225 over 350 times 1 minus 225 over 350 divided by 350. Remember, when you put this in the calculator, I strongly recommend that you're using alpha y equals to get that physical fraction to make this easier. It'll be a lot easier. It'll look just like what you have on your paper, and you won't have to worry about, did I forget a parentheses somewhere when I was doing this? So will you do subtraction and then change it to addition to get your lower bound and upper bound? And so our interval is 0.5927 and 0.6931.
How do I know? Do I
Okay, interpreting your confidence intervals. We are 95% confident that the true proportion of adults that get 7 hours of sleep per night on the weekend is between those two percentages. All right, letter I. Can you conclude that more than 61% of adults get more than 7 hours of sleep per night on the weekend?
Yes.
Because 59 is below 60.
Remember, in order to conclude that, your entire interval must be above that.
Oh.
Sorry, or below that. Sorry. Above that. There we go. Yes. So the answer is no. So yeah, if the value that they're asking falls within your interval, you can't conclude that. All right, find the probability that Z is less than 2.33.
Look at the chart.
Just look at the chart. 0.9901. Find the probability that Z is greater than 1.233. 1 minus 0.9901, which is 0.0099.
I can't wait to see these problems on the exam.
All right. The mean pulse rate for college-age women is 72. One university thinks the mean pulse rate for college-age women is more than that. So H naught, H1. So H1 is mu is greater than 72. H naught either equal to or less than or equal to. So what is power? So remember, that's why I think number 21, I'm like, you got to know that box.
It's you don't reject the null and it's true.
So power is reject H naught when H1 is true. So that's the definition. The scenario would be we reject H naught and conclude that mu is greater than 72 when the average is greater than 72, yes. So what we think is accurate, and that is our power. List 2 ways to increase power.
Money and success.
No.
Have more people
Surround
sleep.
yourself with good people like
Worse
yours.
people.
Increase sample size. The other is increase the difference between the true value and the null value.
Oh, yeah. True value and what?
The null value. So in other words, if for this scenario I had gotten my value as being 73 and the null is 72, they're not very close. If I find that my actual value is 80, I increase the difference between the two, and therefore I increase power.
More true.
Okay?
It's more not false.
More, yes.
We make you look like a arithmetic teacher.
All right. For x with mu equals 50, sigma equals 5, and a sample size of 18, find the following probability.
4
What's the problem?
It's not greater than 30. It's not normal.
Okay, can't do it because it is not, doesn't say normal, and it is not a sample size greater than 30. So that being on there without having, I haven't looked. I'm going to guess they're asking you one of those types of questions. I'm just going to take a wild guess and say that will be on there somehow.
Interesting.
One time, okay? I would say only once. You probably are not going to get that more than once, but one time it's going to be, the answer is, well, we can't do it because sample size isn't large enough or whatever reason it is. Okay, how about number 30? For x with mu is 50, sigma is 5, and a sample size of 33, find the probability x is less than 52. So, remember z is 52 minus 50. Because it does not tell me it comes from a normal distribution, the bottom is 5 divided by square root of 33, the square root of n, okay?
Wait, so anytime it's not normal, you
If it doesn't, like if it's just giving me the data and it does not state that it is normal, that's when I have to use that standard deviation.
Wait,
Yes.
What if it does state it's normal?
We're about to do that on the next problem. Okay? All right. So my z-score here is 2.30. So I am finding the probability of z being less than 2.30. So you're going just to your chart, finding the number.
1 minus.
Nope, it's less than.
But it's a positive number. Why am I tripping?
0.9893. Look at the symbol. The symbol tells you if it's which.
It's under it.
If it's greater than, then it's 1 minus.
Oh, because it's that.
Yes. Okay, 31 tells you it is a normal distribution. Remember when it gives you this terminology, this notation, this is mu, this is sigma. Okay? Sample size of 20 doesn't matter because I told you it came from a normal distribution. So z is 52 minus 50 over 5. So because I know it came from a normal distribution,
Don't have to do
divide by 5, you don't have to do the divided by square root of 33, right? Or square root of n. So my z-score here is 0.40. Still finding less than, so I'm just going straight to the z-chart and finding that answer. And I get 0.6554.
I have a question.
A retailer would like to estimate the proportion of their customers who bought an item after viewing their website on a certain day. How many customers do they have to monitor to estimate the proportion of customers who bought an item with a 5%, within 5%, so your error is 5%, with 95% confidence? So,
I thought we were just looking for it.
we have to go find Z, because 95% confidence means between 0.25 and 0.975.
1.96.
So it's 1.96. Again, my error is
Lock in.
0.05.
Do we get this equation?
Yes, this is your sample size determination. Now, here is what you don't get. If you look at sample size determination, it says you have to know what p hat is. It didn't give it to us.
That's me.
Do you remember what we use for p hat? If
0.25.
so, 0.25, which on the formula, that is p times 1 minus p. Because they're saying p hat is 0.5. Does that make sense? 0.5 times 1 minus 0.5 is 0.25. So if you look at the formula, it gives you p times 1 minus p hat times z star squared over e squared, which I gave it to you slightly differently, but it's the same formula. If you plug in 0.5 for p and multiply by the complement, you get 0.25. We just went straight to 0.25. Okay?
So you're just showing us why it's 0.25.
Yes.
So
I
when
was
I,
like,
when I do this formula, I just do.
You would ignore this and plug in 0.25 because that's what it is. Yes. If you know p hat, then plug it in the formula. Okay, so this is 0.25 times 1.96 over 0.05. You can either do the fraction and square it or square the top, square the bottom. It's the same, doesn't matter. And then you're going to get 384.16. So how many people needs to be in the sample size?
385.
385.
Is it part of the fraction?
It doesn't matter. It doesn't matter. In their formula, it shows it as part of the fraction. It doesn't change it if you pull it out in front because it's not squared. And the way that they have the formula is they square the top and square the bottom. We just did it slightly differently. Doesn't change it. All right, last problem. A university study finds 40% of 12th grade females feel they are overweight. A local high school believes the percentage is less than 40%. Define a type 2 error for this scenario. So we need to know H0 and H1. H1 is that the proportion is less than 0.40. H0 is the proportion is for 0.40. What is a type 2 error?
It's rejecting when it's true, right? Or when it's
Yeah, it's the backwards. It's the false.
Fail to reject H0 when
true.
H1 is true. So specifically, we would fail to reject H0 when the true proportion is less than 40%.